Welcome to Creative World. In this video, I will solve Handa Electrical Engineering book problem. First, read the scenario. Three equal resistors connected in series across a source of EMF together dissipate 10 watts of power. What would be the power dissipated in the same resistors when they connected in parallel across the same source of EMF? Option A 10 watts, option B 30 watts, option C 90 watts and option D 270 watts. So without wasting time, let's proceed towards the solution. Before solving the problem, we will make some assumptions and define some variables. In the question, it is given that there are three resistors and all of them have same value. The value of a single resistor can be assumed as X and the EMF of the source is denoted with variable E. Now read the first part of the question. Three equal resistors connected in series across a source of EMF together dissipate 10 watts of power. These three resistors are connected in series with a source of EMF E. Connection diagram for this series circuit is shown here. These three resistances, each value of X are connected in series with a EMF source E. Their combined resistance will be the product of number of resistances with the value of a single resistor, which is 3 multiplied by X equal to 3X. Because all the resistances have same value, that's why we used this formula. Now we have total resistance of this circuit and the EMF across this circuit. We can calculate the power of this circuit. Total power of this circuit will be E square divided by 3X. And if we focus in this scenario, the power of this circuit is given, which is 10 watts. So we can replace the power with 10 watts. Now we will move towards the second part of the question. What would be the power dissipated in the same resistors when they are connected in parallel across the same source of EMF? In this second part, the connection of resistances is changed from series to parallel while keeping same value of EMF. Connection diagram for the second part is shown here. Total resistance of this circuit will be X divided by 3. And we used this formula because all these resistances have same value. Power of this circuit will be E square divided by total resistance, which is X divided by 3. And E is the voltage across this circuit. Solving this equation, this 3 will multiply with denominator E square. Now in order to calculate this power, we have to omit these variables in the equation. And these variables can be replaced with this value if 3 is multiplied with denominator. In order to make this equation E square divided by 3X, we will multiply and divide with 3. Equation becomes 9 multiplied by E square divided by 3X. Equation of power for this network is became 9 multiplied by E square divided by 3X. And we have the value of E square divided by 3X. We can replace it with 10. And if we multiply these two values, the power of this circuit will be 90 watt. The right answer for this question is option C, 90 watts. Thank you. See you in next video.